Electrical metallic tubing, or EMT, installations require proper support and securement to ensure safety and compliance with the National Electrical Code, or NEC. When it comes to strapping EMT at couplings, several NEC articles provide guidance. Let's explore these requirements in detail. NEC Article 358.30 APWO specifically addresses the support of EMT. It states that EMT shall be supported within 3 feet or 914 mm of each outlet box, junction box, cabinet, fitting, or raceway termination. However, it also specifies that EMT couplings shall be supported within 12 inches or 305 mm on either side. This means that the code recognizes a distinction between general support requirements for EMT and the specific support needed at couplings. NEC Article 358.40b further reinforces the need for mechanical security. It requires all EMT connections to be mechanically secured in accordance with 358.30. This means that any connection, including couplings, must be properly tightened and secured to maintain the integrity of the electrical raceway. NEC Article 358.30b addresses situations where 2 or more EMT are joined by means other than a threadless coupling. In such cases, the joint shall be approved and securely held in place by an approved clamp, strap, or other means. This section emphasizes the importance of using approved methods and hardware to ensure a secure connection. Now, let's interpret these NEC requirements to understand how they apply to strapping at EMT couplings. Firstly, EMT couplings are considered termination points. This interpretation is based on 358.30 ATWO, which mandates that couplings must be supported within 12 inches on either side. This close proximity support requirement suggests that the coupling is treated as a point where the EMT run is essentially terminated and restarted. Secondly, EMT runs between couplings have different support requirements. The 3-foot support requirement for terminations does not apply to EMT runs between couplings. Instead, these runs are subject to the general support requirements outlined in 358.30a, which typically involve longer intervals between supports. However, it's crucial to remember that all EMT connections, including couplings, must be mechanically secured per 358.40b. This means that even if a coupling is not within 3 feet of another termination point, it still needs to be properly tightened and secured. In practice, this means that it is generally necessary to strap EMT couplings within 12 inches of the coupling on either side. This practice ensures compliance with 358.30 ATWO and provides the necessary support to prevent the coupling from becoming loose or dislodged. Additionally, all EMT connections, including couplings, must be securely supported throughout the run, even if they are not within 3 feet of a termination point. This means using appropriate straps or clamps at intervals specified by the NEC to maintain the structural integrity of the EMT raceway. To summarize, when working with EMT and couplings, keep the following points in mind. Firstly, EMT couplings are considered termination points and must be supported within 12 inches on either side. Secondly, all EMT connections, including couplings, must be mechanically secured per 358.40b. Thirdly, EMT runs between couplings are subject to general support requirements, but all connections must still be securely supported. By adhering to these NEC requirements, you can ensure that your EMT installations are safe, compliant, and reliable. Remember to always consult the latest edition of the NEC and local codes for specific requirements in your area. It is also a good idea to consult with a qualified electrical inspector or engineer if you have any questions or concerns about EMT installation. Let's consider some practical examples to illustrate these concepts. Imagine a straight run of EMT with several couplings along its length. According to the NEC, each coupling must be supported within 12 inches on either side. This can be achieved by using EMT straps or clamps that are securely fastened to the supporting structure. The straps or clamps should be positioned close to the coupling to provide adequate support and prevent movement. In addition to the support at the couplings, the EMT run between the couplings must also be supported at appropriate intervals. The specific spacing between supports will depend on the size of the EMT and the requirements of the NEC. However, it is generally recommended to use a maximum spacing of 10 feet for EMT runs. Now let's consider a scenario where the EMT run is making a bend or turn. In this case, additional support may be required to prevent the EMT from pulling away from the coupling or bending excessively. The NEC allows for the use of various types of fittings and supports to accommodate bends and turns in EMT runs. These fittings and supports should be selected based on the specific application and the requirements of the NEC. It is important to note that the NEC also addresses the use of threadless couplings for EMT. Threadless couplings are designed to provide a secure connection without the need for threading the EMT. These couplings typically use a compression-type fitting that tightens around the EMT to create a strong mechanical bond. When using threadless couplings, it is essential to follow the manufacturer's instructions for installation and tightening. The coupling should be tightened to the specified torque to ensure a secure and reliable connection. In addition to the mechanical aspects of strapping and supporting EMT, it is also important to consider the environmental conditions in which the EMT is being installed. For example, in damp or corrosive environments, it may be necessary to use EMT in fittings that are specifically designed for those conditions. The NEC provides guidance on the selection of appropriate materials and methods for different environmental conditions. Furthermore, it is crucial to ensure that the EMT is properly grounded and bonded to the electrical system. Grounding and bonding help to prevent electrical shock hazards and ensure the safe operation of electrical equipment. The NEC provides detailed requirements for grounding and bonding EMT systems. These requirements should be carefully followed to ensure compliance and safety. In summary, the proper strapping and support of EMT couplings is essential for ensuring the safety and reliability of electrical installations. By following the NEC requirements and using appropriate materials and methods, you can create EMT systems that are both code compliant and long-lasting. Remember to always consult the latest edition of the NEC and local codes for specific requirements in your area. And if you have any questions or concerns, don't hesitate to seek the advice of a qualified electrical inspector or engineer. Now let's delve deeper into some of the specific challenges and considerations that arise when strapping EMT couplings. One common challenge is dealing with limited space or obstructions. In some situations, it may be difficult to position straps or clamps within 12 inches of the coupling due to the presence of other equipment or structural elements. In these cases, it may be necessary to use alternative methods of support, such as using longer straps or clamps that can reach around the obstruction. Another consideration is the type of supporting structure that is available. The supporting structure must be strong enough to adequately support the weight of the EMT and any associated equipment. If the supporting structure is not suitable, it may be necessary to reinforce it or use a different type of support system. When working with multiple EMT runs that are close together, it is important to ensure that there is sufficient space between the runs to allow for proper strapping and maintenance. The NEC provides guidance on the minimum spacing requirements for EMT runs. It is also important to consider the accessibility of the EMT system for future maintenance and repairs. The EMT should be installed in a manner that allows for easy access to couplings and other components. This may involve using removable straps or clamps that can be easily detached when necessary. In addition to the physical aspects of strapping and supporting EMT, it is also important to consider the aesthetic appearance of the installation. The EMT should be installed in a neat and professional manner, with all straps and clamps properly aligned and secured. This will not only enhance the appearance of the installation, but also help to ensure its long-term durability. When selecting straps and clamps for EMT installations, it is important to choose products that are specifically designed for use with EMT. These products are typically made of galvanized steel or aluminum and are designed to provide a secure and reliable connection. It is also important to choose straps and clamps that are compatible with the size of the EMT being used. Using the wrong size strap or clamp can result in a loose or insecure connection. Before beginning any EMT installation, it is essential to thoroughly plan the layout of the system. This includes determining the location of all couplings, supports, and other components. A well-planned installation will not only be easier to execute but also more likely to comply with the NEC requirements. During the installation process, it is important to regularly inspect the work to ensure that it is being done correctly. This includes checking the tightness of all couplings and supports, as well as the alignment of the EMT runs. Any problems that are identified during the inspection should be corrected immediately. After the installation is complete, it is important to perform a final inspection to ensure that all work has been done in accordance with the NEC requirements. This inspection should include a visual check of all couplings, supports, and grounding connections. It is also a good idea to perform an electrical test to verify the integrity of the system. In conclusion, the proper strapping and support of EMT out couplings is a critical aspect of electrical installations. By following the NEC requirements and using appropriate materials and methods, you can ensure that your EMT systems are safe, reliable, and code compliant. Remember to always consult the latest edition of the NEC and local codes for specific requirements in your area. And if you have any questions or concerns, don't hesitate to seek the advice of a qualified electrical inspector or engineer. Finally, let's consider some advanced techniques and best practices for strapping EMT couplings. One advanced technique is the use of prefabricated EMT supports. These supports are designed to simplify the installation process and ensure consistent spacing and alignment. Prefabricated EMT supports are available in a variety of configurations to accommodate different installation scenarios. Another best practice is to use a torque wrench when tightening couplings and supports. A torque wrench allows you to apply the precise amount of torque specified by the manufacturer, ensuring a secure and reliable connection. Over-tightening can damage the EMT or coupling, while under-tightening can result in a loose connection. When working with long EMT runs, it is important to use expansion couplings to accommodate thermal expansion and contraction. Expansion couplings are designed to allow the EMT to move slightly without putting stress on the system. This can help to prevent damage to the EMT and couplings over time. In areas where there is a risk of physical damage to the EMT, it is important to use rigid metal conduit RMC or intermediate metal conduit IMC instead of EMT. RMC and IMC are more durable than EMT and can provide better protection against physical damage. When transitioning from EMT to RMC or IMC, it is important to use appropriate fittings to ensure a secure and watertight connection. These fittings should be selected based on the specific application and the requirements of the NEC. In corrosive environments, it is important to use EMT and fittings that are made of corrosion-resistant materials such as stainless steel or PVC-coated steel. These materials can withstand the harsh conditions and prevent premature failure of the EMT system. When installing EMT in concrete, it is important to protect the EMT from corrosion by wrapping it with a layer of plastic or applying a corrosion-resistant coating. Concrete can be corrosive to EMT, so it is important to take precautions to prevent damage. When running EMT through walls or floors, it is important to seal the openings to prevent the spread of fire and smoke. Fire-stopping materials should be used to seal the openings around the EMT and maintain the fire rating of the wall or floor. Finally, it is important to keep accurate records of all EMT installations, including the location of couplings, supports, and grounding connections. These records can be helpful for future maintenance and repairs. By following these advanced techniques and best practices, you can ensure that your EMT installations are not only code compliant but also durable, reliable, and easy to maintain. Remember to always consult the latest edition of the NEC and local codes for specific requirements in your area. And if you have any questions or concerns, don't hesitate to seek the advice of a qualified electrical inspector or engineer.